Hey, it's Miss Smart with your Lesson 7 practice problems from Unit 6. This is on page 56, and you were just doing numbers 1 through 4. Oops. So page 56, 1 through 4. Okay, so the first question is, again, going to be about coordinates for points on this clock. The clock is centered at 0, 0, so this would be the x-axis, and this would be the y-axis. And I know there wasn't a clock printed in your textbook. I just made a little copy of that one and stuck it on there. You could just draw a circle as well. The minute hand is 10 inches long, and find the approximate coordinates of the tip of the minute hand at these different times. So at 12:05, the minute hand is going to be pointing at the 1. And so I'm looking, whoopsies, hold it off. That's okay. So the minute hand is going to be pointing at the 1 at 12:05. Now the length of this minute hand is 10 inches. And so thinking about when it comes to, well, how far around the circle is this? And you can make from 0 to pi, you can make 1, 2, 3 sections that are that same size. So that means this angle right here is at pi over 3. So the x coordinate would be 10, because of the minute hand is 10 inches, times the cosine of pi over 3. And then the y coordinate is 10 times the sine of pi over 3. Okay, and so the cosine of pi over 3 is right here. It's 1/2. Half of 10 is 5. So this is really 10 times 1/2, which is 5. And then for the sine of pi over 3, I'm going to use my calculator for that one because that is going to be an irrational number. So 10 times the sine of pi over 3 is about 8.66. Okay, so these would be the exact coordinates. This would be the approximation. Over here at 12:45, that's when the minute hand is pointing right at the 9. And at that time, here we go, this is pi, so the cosine is -1 and the sine is 0. So if this is 10 inches long, then I would have 10 times the cosine of pi, which is -10, and then 10 times the sine of pi. The sine of pi is 0. 10 times 0 is 0. Okay, so -10, 0. And then 12:55. 12:55 is when the arrow points at the 11, which I've already highlighted there. This is if this is pi over 3, this is 2 pi over 3, or 2/3 of pi. So 2 pi over 3. So the exact coordinates would be 10 times the cosine of 2 pi over 3, 10 times the sine of 2 pi over 3. Okay, so 2 pi over 3 is right here on the unit circle. The cosine is -1/2, which means 10 times the cosine would be -5. So 10 times 1 times -1/2 is -5. And then for the other coordinate, I'm going to use the calculator. Although, do I really need to? Because I already found it over here, and this is going to be the same value. So I'm just going to use the value from part A, 8.66. All right, number 2, the center of a Ferris wheel is 100 feet off the ground and its radius is 85 feet. So we did a problem really similar to this today. This is 100, this is 85. A is at 0 radian position. B is rotated 7/12 of pi, or 7 pi over 12. And C is rotated 5 pi over 4. Both of those are in relation to A, which is at 0. So again, we're rotating in this direction. For each point ABC, find how high the position on the Ferris wheel is off the ground. So point A is level with the center of the Ferris wheel. So for A, I would just say 100 feet. Now for B, it's going to be 100 feet plus some more. So thinking about, okay, well, here's the rest of the diameter. Straight up, we're at pi over 2. This is slightly past. So I'm trying to figure out this height right here. And that's going to be just, not quite 85, a little bit less. It's going to be exactly 85 times the sine of 7 pi over 12. That's just for this piece, and then we add on the 100 for how high it is off the ground. Okay, so 85 times the sine of 7 pi over 12, and then plus 100. 182, about 182.1. feet. And then finally, point C. So point C is at 5 pi over 4. And when I look at the unit circle, 5 pi over 4 is right here. Its sign is negative root 2 over 2. So I'm going to use the calculator one more time. So 85 times the sine of 5 pi over 4. The sine of 5 pi over 4 is a negative number. When we multiply it by 85, we'll still have a negative number. But then once we add it to the 100, we'll get a positive number because obviously the Ferris wheel is not going to be underground. So we'll add on 100. Okay. So 85 times the sine of 5 pi over 4, and then plus 100. 39.895, so about 39.9 feet. All right. Next, a Ferris wheel has a radius of 50 feet, and its center is 60 feet off the ground. How many points on the Ferris wheel are 30, 110, and 5 feet off the ground? Okay, this is a great question and a really good time to use a diagram. So I'm going to make a diagram similar to the one that's on number 2. So we have a circle. And then I'm just going to go ahead and draw this in. And then this would be the ground right here. Okay, so the Ferris wheel has a radius of 50. The center is 60 feet off the ground. Okay, so the radius is 50. But the center right here is 60 feet off the ground. Okay. And so let's see here. I guess this isn't drawn super well to scale, but that's okay because this little part right here is a distance of 10 from there to there. Because if the radius is 50 and it's 60 altogether, that little piece of it would be 10. Okay, so 30 feet off the ground. 30 feet off the ground will happen in quadrants, sorry, 3 and 4, because 60 would be like for quadrant 1 and 2, above 60. So between 10 and 60 would be quadrants 3 and 4. So it's going to happen twice. Once in quadrant 3, and then it's kind of the same level in quadrant 4. So 30 feet off the ground, that will happen 2 times. 110 feet off the ground is only going to happen once, because that's the total of 60 plus 50. So right here at the very tip top, pi over 2, the height is equal to 60 plus 50, which is 110. And then that's the only time it's going to equal that, so just one time. And then 5 feet off the ground, hopefully never, because that would mean someone fell off the Ferris wheel, since this is at a height of 10. So I'm going to write 0 there. All right, finally you had number 4. The minute hand on a clock tower is 6 feet long. At 10 minutes after the hour, the tip of the minute hand is 55 feet above the ground. How high above the ground is the center of the clock? Ooh, this one's a little bit tricky. Okay, so let's look at, I just grabbed this little clock diagram once again. I'm going to let it go ahead and cover up number 5 since you didn't have to do that one. Let's tape it right here. So whenever we have a diagram like this, it is really helpful to draw in the axis, the x-axis right here, and the y-axis right here. Okay, so here's the center of our circle, 0, 0. At 10 minutes after the hour, so 10 minutes after the hour is when this is pointing at the 2. So the minute hand is pointing at the 2. And the minute hand is 6 feet long, so this is 6. Okay, the minute hand on a clock tower is 6 feet long. At 10 minutes after the hour, the tip of the minute hand is 55 feet above the ground. So 55 feet above the ground, here's the tip of the minute hand. And let's say the ground is down here. I know this total distance is 55 feet. Okay, so I'm going to focus on if that whole distance is 55 feet, and I call this like maybe y, just from here to here is y, then I'm going to say the answer, what I'm trying to find, is going to equal 55 minus y. That would give me this part of it, which is going to be the height of the center of the clock as well. And so all I have to do is figure out that part. Well, I know that at that point right here, that this is equal to pi over 6. I know that the sine of pi over 6 is equal to 1/2. And so if y is equal to the sine of pi over 6, which is 1/2, then, oh, I should have actually clarified. It's then this distance right here is equal to 3 times that. I meant 6 times that, and the answer is 3. Okay. So I know the sine of pi over 6 is equal to 1/2. So I'm going to just That's not quite what y is. It's just a little bit of work I needed to know to figure out what y is. So if the sine of pi over 6 is equal to 1/2, and y is equal to 6 times that because of the length of the minute hand, then y is equal to 6 times 1/2, which is 3. So I know from this whole distance, this little part right here is 3 feet, and this part right here is 55 minus 3. So 55 minus 3 is equal to 52, which means the center of the clock is at a height of 52 feet. All right, and that is the final answer on number 4 and the last problem on your assignment.